First radios used turn of the century were simple induction coil type of radios, no batteries, no electric current, no electron tubes. They were just actually just two simple coils, and they had to control the frequency of the radio signal itself, so they used silicon carbide crystal, and on top they had a small wire where you would locate a sweet spot, and this was called a cat whisker diode, and it's one of the first diodes that was not a electronic tube type of design or integrated circuit, and it's a very simple design. And Captain Henry Joseph Brown was the first to discover at certain spots that crystal would actually light up because it was behaving as a diode, and this was actually the first reported examples of a lighted diode. Integrated circuits are probably the greatest invention of all time to actually integrate on a microscopic level layers of transistors, resistors, and capacitors. And the only problem with these types of circuits is they're not repairable. You simply replace them. In a survival situation, and through personal experience, these fail all the time, not only in hardware but in the firmware programming. So this is a rectifier that's commonly used in AC circuits to convert alternating current to DC. As you can see, it's a fluctuation of positive, negative, and it goes in through a electronic circuit, and your output is direct current. Slight pulse on this simple circuit that you see in the middle is actually diodes. Now you could take a integrated circuit and convert it to more of a hardware type of circuit that is repairable, and this circuit has actually diodes themselves. It's not integrated, and depending on how you design your circuit, this one has capacitors to clean up the pulse that does result with the rectifier, diode rectifier. But KipKey has kits where you can actually make your own LED light by hardwiring these devices. And like I said, even though capacitors can also fail, especially the plastic ones, but if they're kept cool, and in this case this kit uses 38 T1 LEDs, they're very low in thermo heat, and actually these diodes can actually last the rated 50,000 to 100,000 hours, and with a hardwire circuit, if one of these diodes or resistors fails, if you had backups, you can easily repair this circuit. Now theoretically, you don't even need, if you're working with direct current such as a battery, you don't really need much of a circuit in this case. This is a 9-volt battery. You can my circuits are 12 volt, and if you can size your diodes depending on the resistance, the total resistance, how many voltage you have across the circuit, by adding up the voltage of each diode, you can directly hardwire a diode set. Say you had a set of diodes that added up to 9 volts for this battery, you wouldn't need a resistor. But in the real world, batteries fluctuate in voltage and internal resistance, and resistor is a safety valve to keep, or we don't want to burn out our circuits, especially an LED, a lighted LED, because they're so fragile. So basically the survival circuits that I build are simple DC circuits. You don't have to work with fluctuating alternating current that is high voltage, which is also can cause a lot of thermal stress on your circuit. Simple DC circuits, when you're not dealing with a lot of luminous, of course the key is to have your life cycles of your components last as long as possible, especially your diodes, and low heat, low luminous lighting is such as this one. If you're using color to white lights, so obviously using white diodes would be your longest lasting circuit.